This podcast was produced by OAR FM Dunedin with support from New Zealand On Air.
The Science Notes podcast on OAR FM Dunedin, brought to you by the Division of Sciences at the University of Otago. I'm Dave McMorrin. Over the next half hour, I'll be chatting with a graduate science student about their research, their passion for science, and the things that fuel their creativity. Well, welcome to Science Notes again for another episode. My name is Dave McMorrin, and this time our guest is Daniel Zamorano. Have I said that right?
Yeah.
Daniel is doing a PhD.
I finished.
You finished your PhD.
Yeah.
Yes, we did talk about this by email. In zoology at Otago University. So how long since you submitted?
3 months.
Okay, so you were just waiting for the
Next step in my life.
Yeah, the next step out into the real world. But we'll be talking a little bit about what Daniel's been doing for his PhD work. You have an accent which would suggest that you're not from Dunedin originally.
No, I am not.
So where are you from, and how is it that you ended up doing a PhD at Otago?
I am from Chile.
Right.
So I work in science like 10 years before coming here.
Okay.
But the main reason because I am here is because of my wife.
Right.
My wife was looking for doing a master at the science communication department.
All right. Yep.
And she told me like, what do you think about Dunedin?
Because you can do, to be fair, you can do zoology in most places, but the Science Communication Centre at Otago is relatively unique in the world. So you came here for that.
Yeah. So I started checking the professor at the Zoology department, and I liked what I saw. Disturbance, niche modeling. I was looking for working with rivers, with the streams.
Right.
I thought it was very cool, the connection between the landscape and the biological thing and the environmental context of those funny networks of rivers being connected one each other, going all together to the sea eventually.
So was this the sort of thing that you were doing back in Chile?
In part. In Chile, I started being a botanist, working with invasive plant species.
Okay.
But then came Didimo to Chile.
Right.
I started working in a company, in a consultancy, working with Didimo.
Right. So listeners, at least in New Zealand, might be familiar with Didimo. I'm sure it's still a thing, but I seem to remember a few years back, it was in the news all the time, and there was all this business about how you had to wash your boat before you moved it from one lake to the next to stop the spread of Didimo and stuff.
Still, you need.
And so this became a problem in Chile as well.
As well.
Right.
The southern Chile is very similar to New Zealand.
Right.
So we had the same thing, the same problem. Didimo started popping up in all the rivers around, and everybody was like panicking. So most of the literature I was checking on Chile was from here.
Right. Okay.
Yeah, because New Zealand were very ahead on researching Didimo, and we in Chile we were just starting.
Right. Yes.
So,
in fact, long-term listeners of this show, assuming there are any, may remember about 5 or 6 years ago we had someone on the show who from zoology, I suspect, who was studying Didimo for their PhD.
So the Didimo was a thing 10 years ago, and everybody was like, oh yeah, Didimo money, and the government were keen to pay you for researching it.
Yep.
Now, it's common.
Is that because it's just common and people are just going, oh well, never mind? Or
I think first the concern that we rise up about how you will spread this algae makes sense to everybody, and now I think everybody is more careful about it. And without the gumboots, do you remember the gumboot that had like a ghoul on there? Those gumboots are not available anymore. I think that this is helping a lot.
Okay.
But at the same time, streams have their own rhythm, and they got rid of whatever is an excess.
Sure. Right. Which, of course, is from my understanding of what you've sent me, kind of what your PhD's been on, is this whole process of how things like Didimo establish in rivers and then move on again.
Yeah.
But you haven't been studying Didimo as such here.
No.
Have you been studying a specific thing, or has it just been more generally, this is how these sorts of organisms live?
So when I was working with Didimo in Chile, and then I started planning my PhD proposal, I realized how many open questions we had about algae community on rivers in general, because the microworld were not researched at all for many, many years.
Yeah.
Everything about ecology in microworld research is very postponed. We need to realize that while we can see a lion, how they behave and hunting, and we can check the creators living and being drunk, dancing with fruits, we cannot do the same with algae or whatever. It's macroscopic. So I tried to do something like Didimo with Didimo, and then I started going back in literature. I found many open questions, and at the end I finished doing something very theoretical about how these communities organize each other, how interact one with each other, and making very easy question, naive question that face the open challenge of this area, trying to make the big ecology with the micro world in rivers.
Right. So Didimo is an example of one of these organisms, as we were talking about just before. This is kind of if people are familiar with like rivers and stuff in New Zealand, then it's the kind of the slimy stuff that you get on the rocks. These sort of films or mats of algae, is it mostly? So little plants.
Yeah.
But rather than sort of individual plants, they're growing in little communities and they're all kind of tangled up together somehow. Yeah. So these are lots of different species.
Many. Like in one sample, in one rock, you will find 60, 80 species living together. And in millions of them. There are microscopical that are smaller than a micrometer. But many of them are 10 micrometers, 20 micrometers. But while our first intuition about them is like a tiny forest, you know? The algae is a tiny forest, so the rock is a mountain on the river, which is very interesting. But at the same time, algae are more funny than that because most of them move. Some of them swim, another glide over surface.
So they're plants, but they're not kind of rooted in one place and dropping seeds, and then the small ones grow in the same place. They're potentially moving in and out of the community all the time.
Yes. So, but they move at a micro scale, you know. Didimo doesn't move, but they start going up with the stock. You remember the Didimo had a stock?
Mm-hmm.
So you have the algae. The algae produce plastic, let's say, or paper for being attached to the bottom, to the stream bed, and then produce more paper, and going up, because the algae want to be attached but closer to the sun.
Yeah.
So we have many of those algae, because Didimo is not the only one who does the same. We have algae that start doing filament one next to each other.
Right, yep.
And we have the one who moves, swim. But this happens at the micro scale. So the big question is which consequences we can observe at the macro scale, at our scale.
Yeah. So the little creatures can move around to an extent by themselves.
Yeah.
The question is, if they're in a river, say, to what extent can they move just because of the current of the river moving them around?
For example,
right.
There is a big average that an algae, a diatom, can move 24 centimeters per day.
Right.
So it's a funny metric, because that means that an diatom can change house, can move from a mountain to another mountain in one day.
Yep.
But in average, they live like 4 days. So the consequences of this micro movement in the big ecology is the thing we need to face now, because we need to face the open question, and that is one of the open questions.
And this is what I find, this is what I always find interesting about talking to people on the show, is that there's things which you think people would have worked out years ago, but they haven't, right? So people don't really understand how these little creatures as part of these communities move, and how the communities can change as some things move and some things don't move and whatever. And this is going to be important for understanding the processes that happen in the river. And
I have the awful feelings that we had a generation that knew this very well.
Yeah.
At the end of 1990, where a set of people around the world, here in New Zealand as well, that knew a lot of perphyton. And then the research stopped.
Right.
Laboratory didn't get more people, I guess, no more funding, or just nobody took the same path of research. So I think we lost a lot of experience on perphyton, which is very sad. but cannot be helped.
Yeah.
So we need to try to keep going.
It's now your job.
I hope so.
So you said that there are these unanswered questions in trying to understand how these little creatures live and these little plants live in the world. So in your thesis addressed 3 of those, I think.
Yeah.
So maybe we could talk a bit about what those questions were and the experiments that you did to try and answer these questions.
So the first silly question was, how far? Because everybody knows the algae move far. Yeah, they can go in the sky, in the wind, on the feet of fisher people. How you say? Fishing? Fishers?
People who fish.
Sorry, yes, perfect.
Yep.
And they can move. But there is not that many effort estimating how far they can move. And the main dispersal vector for this algae still is the river going downstream.
Yep.
So I did an easy exercise of leaving tiles, ceramic tiles, in many sections of the river, but downstream of the Sullivan Dam, because lake algae is different than river algae.
Oh, so sorry, Sullivan Dam. So that's the one just up the hill here from up the hill. You don't know if you're listening. This is up on the northern motorway out of Dunedin.
Yep.
Yeah, it's lovely up there. Nice place to have to work.
So the question was easy, like how far from the dam we could find lake algae on the river.
Right.
And with that, we were able to estimate an average of 1 kilometer, 500 meters that an algae can move downstream.
Which seems to me like a long way for such a small creature.
Exactly.
Small thing, yeah.
But this is small for landscape consequences, like probably if an algae star in Wanaka won't go all the way down to the Cluta in one day, but at the same time they are macroscopic. So how we match this expectation is very funny. But yes, we got a number, but this is a number very determined by the stream. We, following the data, we understand that if the river channel will have less turbulence, the algae will settle more. But the funny thing is that we found more differences between intra-species than between species. That the cell condition, it was most important, for example, the morphology of the algae. Because we have many morphology, we have colonial algae, filamentous algae, those were not that important. But from the simian taxa, let's say taxa, the slower algae, the shorter algae travel 50 meters. And the longer algae will travel 3 kilometers. So while there is a lot of difference for a same taxa on travel distance, that is very interesting because apparently all of them have the opportunity to at least 10% of them can have very, very long trips downstream.
Yeah. Do we know whether there's how do I ask this? Are there some algae that move that far because that's what they want to do as part of their life cycle? Or is the distance that they go just based on how fast the water's going where they find themselves living?
I think it's more the second one. But algae can control their buoyancy for settling. But there is more research on that in marine science.
Mm-hmm.
But that are not the stream.
So
in marine science, people know that algae follow light, and in lakes as well. If there is night, they go down. If there is sun, they go up, and photosynthesis.
Mm-hmm.
But we don't have any clue about what happened on rivers with that phenomenon. Of if they want to settle in a good place. Because evolution for algae is like if I am in good condition, I want to float.
Yep.
But in rivers, you want to settle.
Yep.
Nobody's researching that. And I hope that somebody give me money for doing it.
So you set out these ceramic tiles then at different distances down, and the idea was that you could then look and see how quickly the algae started growing on the tiles, and what types of algae were growing.
Yep.
And the ones that went furthest tended to be the ones that were better designed to float rather than stick.
The thing is that there is a lot of research in environmental conditions. So we know that with pH, some algae grow up. If there is too polluted water, some community grow up. We know about that. it's not an specific knowledge, but there is an intuition well supported that algae have environmental requirements, and we know those well. So my question were more like but what about themselves? Are they interacting with each other, and are those interactions impacting on the final algae forest we are observing? Because that I focus my thesis on dispersal and in facilitation through the biofilm.
So it's a bit like the understory in a forest.
Yeah.
You have the big trees and then you have the little trees, and the big trees need the little trees and the little trees need the big trees.
Yeah.
So that's kind of what you're trying to do with the algae. You're trying to not just one particular one, but the community of them.
Yeah, because you need to picture, if we're talking about forest, if it will be just forest, it will picture that we have a record of all the forests in New Zealand, and we have the soil composition, and we have that's two giant data set, soil composition and forest community. And we match them and we explain 60% of variance. Sure. And we say like, we're explaining the community.
Yep.
But because we see the forest, because they are as big as us, we know that the big trees are different than the small trees. So that was my perception. My initial perception was like, we will be doing the same question to the algae if there will be as big as us, looking through that mirror, to that window. I started thinking in my proposal, and it was like, how far they move. So the second chapter in my thesis is the second experimental chapter. I cover the riverbed with plastic. Is that one?
Yes, I've seen the pictures, yeah.
It was a very naive question, because it's like, what happens if an algae, a rock in a river doesn't have a neighborhood? Other algae, other mountains around will be the same. So where the algae come from? If I have a rock here in the river, in the middle of the river, where do algae come from? For now, we know they all the way around. So it's not specific. So when I cover the river with plastic, I let those rocks to make their own communities just with algae from upstream that is flowing in the flow.
Sorry, just to be clear, because I've seen the pictures and I can't show the pictures on the radio. But you've covered the river bed with the plastic, so the water's flowing over the top of the.
Exactly.
It's not over the top of the river so much as it's over the top of all the river bed.
Yeah.
And then you're taking rocks that already have communities of algae on them and setting them on the plastic.
With clean rocks.
Clean rocks.
Yeah.
And then as the water comes down, you're looking at how the algae start accumulating on the rocks and which ones accumulate.
Exactly.
Right. Lovely. Yep.
So the principal idea we had is that algae with better dispersal traits, swimmers, motile algae could reach those rocks easily and settle there instead of any other algae. But there is many hypotheses on dispersal on algae. Like a filamentous algae should be more probable that they are dragged by the current, many stuff. Most of these ideas were not supported, but for flagellate algae. So we now know that 50 meters of plastic cover is very important. Is a good distance for forbidden or making difficult algae dispersal, and the algae and the rocks need the neighborhood for having more algae.
Right. Yep.
So the next question that came: what will happen if we would put a 10 meters plastic on the river, 2 meters plastic? So the next question will be like, so how far they can go in their own neighborhood? They can reach a stone easily if it's at 2 meters of their self, 3 meters, 10 meters. I think that is the next step of that research. How far an algae? For now, we know that those 50 meters were like, okay, we cannot pass through this plastic. It's too far. But still the rock got some community from the algae coming from the flow. But it's not the same community that the algae upstream.
Right.
So yes, still many. That research is just many open questions.
This is the thing, isn't it? When you start answering questions, you answer some, but then you make some more questions.
Which is very impressive.
It's annoying. It's why you want to do an American PhD and spend 7 years doing it. But maybe you don't want to do that too.
No.
Time's running down, but I was wanting to. There's something in your introduction to your thesis I found really interesting about this business about the pollution and how the pollution levels in the water affect the communities. Can you, in like 2 minutes, explain what you found about that?
So, like any forest, we like diversity, and there is a diversity on periphyton that we need to take care of because we care about diversity. We are changing all the rivers around the world, and particularly in New Zealand, where we have that much pollution on rivers. So, but the sad part is because we don't know so well our periphyton communities, we don't know what we are losing or what we should be expecting.
Yep.
And then we trust in invertebrate indexes to invertebrates telling us if the river is healthy or not. So because there is invertebrate and there is fishes, we can assume that everything is okay. But for now, if we have lose some algae species on rivers because of pollution, we don't know.
Yeah.
Probably we never will know because
all these algae, they're food for things, aren't they? I mean, they exist for their own rights, but they also tend to be food for higher
for invertebrates,
for fish or whatever. So, so if the pollution is such that it kills the algae, then it's going to have ramifications further up and up and up. And
generally, a river like that is a dark river. A river that is so polluted that it's just bacteria growing and nothing else. That is the river we don't want.
Yeah. So the more we know about the simplest ones, which is like you say, they're not trees, so they're not something that we interact with the same, but they're still really important.
It's still really important.
We still understand.
And a little bit science for this is at the beginning the river was empty for us, but now it's full of algae, it's full of invertebrates, it's full of fishes. So now we know the river is full, but it's because of the knowledge of we and our ancestors and all the humanity looking at the river and making questions to the rivers, like what is living here? We know more now, and I want to ask knowing more in the future.
Yeah. So what is the future then? You've finished your PhD.
The future is survive Dunedin.
So the plan is to stay in Dunedin?
Yeah. That's the plan. My wife is working.
Right.
She's a communicator.
Right.
So, yes, what can I do? I don't know. The future now is applying for postdocs,
sure.
Trying to do more research.
Yeah.
Nothing clear for now, but I am hopeful about something good is coming, and I hope that there is money for making more questions to the river.
Yeah.
And more questions to the periphyton, because I consider that we really can learn a lot from them. So, yes, I hope that something good coming.
Great. Well, all the best for whatever's next for you, and thank you for coming along and telling us about what you've been up to.
Thank you very much for the invitation.
And thank you everyone out there for listening. As always, we will finish with a piece of music that Daniel's brought along.
So this music is the music I hear at the lab, and I want to dedicate it to my wife as well.
Very good. All right. Thank you for coming along, and thanks for listening.
This podcast was produced by OAR FM Dunedin with support from New Zealand On the Air.